So it's my great pleasure to be joined again by Dr. Chris Horne, Chartered Electrical Engineer and Director at Myenergi. And we're going to continue on looking at BS7671 Amendment 1, and we're looking at it from a point of 3-phase and EV charging points. We've looked at a couple of indents before, Chris.
Yep, so...
Just go through 1 and 2 for me again in there.
Of course, yeah. So this is all about protecting the end user in an installation with a TNCS earthing system if the pen conductor in the street gets damaged. So that's the context. So what can you do? Well, if you've got a 3-phase installation and you can guarantee that the load on that 3-phase installation is always going to be balanced in such a way that your voltage between your protective conductor and earth, true earth, doesn't go above 70 volts, then crack on.
So that means for 24 hours a day, you've got a balanced 3-phase installation, and therefore, yeah, it's never going to happen, is it? So we know that one's not going to happen.
No, that's not going to happen. So that's ident 1.
And my favourite is the next one.
So ident 2 is dig up your drive, Mrs Goggins. I'm going to put a huge, great earth mat in here and then connect that to your installation earth.
That's got to be the way forward. I think
every job.
Yeah, every job.
Yeah.
Well, obviously, we won't use that one either.
You've lost it again, yeah.
Sorry. So we're now into where we want to look at in this video. We're going to look at indents 3, 4 and 5, and we've got a rig behind us that you think can simulate some stuff that goes on in indent 3?
Yeah, so this is explaining the context. So you've got the, so 3, 4 and 5 are the practical ways of providing safety. What this does is measures the voltage across 3 phases. So we've got a 3-phase supply here, we're measuring line 1 to neutral, 2 and line 3 to neutral.
Okay.
And then the really important one at the bottom, this is the voltage between your CPC and true earth.
So exposed conductive part and touching the greater mass of earth, that's the voltage would appear between those 2 points.
Right. Yeah, and that's what this amendment is all about, making sure that you don't get exposed to a high voltage at this point that could hurt you.
Okay, so that looks pretty good. So we've got a reasonably balanced, so slightly out on L3, but we've got a reasonably balanced 3-phase load, and there's negligible voltage appearing at the bottom.
That's correct, yes. So what we need to do now is let's introduce some imbalance in the street outside.
Okay, so what we're saying there is that properties number 1, number 2 and number 3 are on 3 different line conductors.
Yeah.
They're not all carrying exactly the same load at the same time, so therefore they're out of balance, and then see what that effect has.
Exactly, yeah.
Is this where I get a chance to press some of these buttons?
Remember, on a 3-phase system, if you've got a completely balanced 3-phase system, there's no neutral current flowing.
Absolutely.
When it's unbalanced, this is what drives this voltage and current. So let's have a look what happens.
Okay, so twisting,
yes. Okay, so now we've introduced some imbalance in the system, and you immediately see that the voltage on these 2 phases, well, actually you don't see anything, do you? Because the pen conductor is intact.
Right.
So everything is exactly safe, and you've got no voltage rise there. So that hard work you put into changing that switch made no difference to our system at all.
Okay, all right. So let's just recap then. So we're now not gotten balanced all 3 houses, and there's no issues.
No.
Well, that's what we'd expect.
Well, that's why the system's designed. That's why the pen conductor in a TNCS works, because it does this.
But you're going to tell me next I'm going to break that pen conductor?
All right, so the other switch now.
Yes.
Okay.
So this means the combined neutral earth in the street has now been severed.
Yeah. And you immediately see the change in the voltage going on here. So look, 2 phases here have dropped. Yeah. But you put a voltmeter on that, you wouldn't really be too fussy.
You wouldn't be worried about 222.
If you're measuring this one, you'd be scratching your head thinking, well, why has that gone up? There's something wrong here. Okay. And the one we're really interested in, the one that will give you the nasty shock if you're touching exposed metalwork, this has gone up to 50 volts now. So that's going to hurt. It'll be in a bit of a tingle. You don't want to be doing that.
Okay, and what's happening in the system under indent 3 then? Are we disconnected the supply?
No, we're not.
So so we've left with 50 volts now between exposed metalwork and true earth?
Yes, exactly.
Because it needs 70, doesn't it?
That's right. Indent 3 says if the voltage between the CPC and true earth goes above 70 volts for up to 5 seconds, so 1, 2, 3, so 5 seconds, you need to isolate the output to the electric vehicle.
And it hasn't done?
It hasn't done, so because it's only 50 volts, not 70.
So imbalanced load, very obvious. A broken pen conductor, combined neutral earth, which is 500 volts a year last time I looked. Yeah. And we're still not disconnected the circuit. So how's it going to disconnect then?
So, okay, so the Indent 3 says if the voltage between the CPC and true earth goes above 70 volts, you must isolate the output. So let's introduce a bit more imbalance on the system, because that's when it would happen. And now we've got 70 volts. One voltage has gone significantly out, and the other 2 are still, they're low, but you're a bit worried, but
Yeah.
Okay, so this now, under Indent 3, should isolate the output.
Because it's gone above 70.
Now that would be based on if you had a second earth rod, a reference earth rod.
Okay.
So it doesn't have to be a fully rated one, it's just an earth electrode in the ground.
Yes.
There's requirements about how big it is. You've still got to run it back to your EVSE.
Okay, yeah.
And you must trip on that. Okay.
Right, okay. So I'm a little bit sceptical because we had to do more and more things to get it to trip.
And we don't like earth rods.
And we definitely don't like earth rods.
So this is where Indent 3 says, but you can do it in the electric vehicle equipment if you want to. So if you can work out that you've got a problem with your supply, your pen conductor, and you can trip it before that voltage goes, well, if that voltage goes above 70 volts, then you don't need to have the earth rod.
Right.
You can do it by doing some clever maths on the voltages here.
Okay.
So here, if the manufacturer's put in some protection, it says, okay, if my voltage on any one phase is out of range, trip, then we'll trip. So here, they would have tripped on R3.
Got to definitely.
And the nice thing with this is even if the voltage is lower, 288 volts is still well above your 253 maximum.
And it would have tripped?
So a manufacturer could use this to make sure that you go at a lower voltage.
Yeah, so then we've gone below 70, we're at 50.
Yeah, but it doesn't mean, the regulations don't make you do that.
Right.
It's up to the manufacturer to decide how they will do it in order to make sure this doesn't go above 70.
Right. Oh.
So, okay, now we'd go a lot lower than this, so. Okay.
Any other points you want to raise on that one, or are we looking maybe at moving on again?
Okay, so the other point with Indent 3 is it says that you shouldn't close if the output, if the voltage between CPC and true earth is above 70 volts.
Right.
Then you shouldn't close the output. So you can't reset the device if the fault is still there under the Indent.
Well, and that makes logical sense, doesn't it? So if 70 volts is still present there, the contactors can't reconnect.
That's right, yeah.
Okay, so shall we now have a little break and maybe look at Indent 4?
Okay, I know.
So that's covered Indent 3 in BS7671's Amendment 1. We're going to look at Indent 4 now, Chris.
Okay, so Indent 4 refers to single phase installations. Okay, so you're putting a single phase charge point on the wall. We still don't want to put an earth rod in the ground.
No.
So this is where the IET looked long and hard at this, and they did a risk assessment to look at what happens and how often there might be a fault that would cause an injury. Okay. And Indent 4 says you can put a single phase charge point on the wall. You don't need to install an earth rod, provided that charge point trips if the line to neutral voltage falls with outside 253 to 207 volts, 207 to 253 volts.
And that's a plus 10 volts.
Plus or minus 10 volts. Okay. So that seems quite logical, isn't it? Because we've seen that the voltage can move.
Yes.
When there's an imbalance, let's trip. Okay. Can we have a look at the test rig again?
Yeah.
And let's have a look at this situation. So
I'm looking for that 10% movement now.
Yeah, exactly. So we've got single phase charge point installed on this supply. Remember, it's 3 phase in the street, so you're only taking 1 phase into the house. Okay. So Gareth, you want to introduce some imbalance for me first?
Is it this one?
First one? Yeah.
I'll rotate this. So now we've got house 1, 2 and 3, as we said before, not exactly loaded the same. There's an imbalance.
And the pen conductor's intact.
Good.
All lovely jubbly.
Yeah.
Let's have the fault.
I'm going to put, so remember, this when I do this one, this is a broken combined neutral earth in the street.
Okay, so there's still loads on it in the street.
Yep.
And the voltages have moved. If you're on L3,
yes,
288.5, it's above your range, say you've got to trip.
So if I had an EV charging point plugged in on line 3, that would trip.
It would.
Yeah. Oh, great.
Nice and safe. Okay.
What if I was on line 2?
Well, the earth voltage only reached 50 volts. So not a problem.
Okay. Yeah.
Good. If I'm on lines 1 or 2, though,
don't get a go.
Not going to go, is it?
No, because it's floating around what we expect it to be. There's
that's fine. So 50 volts, enough to tingle. Okay, but it's not going to kill you at that voltage. But it's still not tripped. So 3 houses, all outside. Yeah. EV charging point there. Yeah. One's not working. The other 2 would be working. That's right. Yeah.
Oh, right. Okay.
Let's put some more imbalance on the street.
Okay, so all of a sudden there's a little bit more imbalance.
Okay. So now we already know this phase is going to go. That one's safe.
It's nice and safe.
These 2 still happily charging the car because it's not gone down to 207. Have a look at the 70 volts. Yeah. So this is where the IET, even in the guidance notes for installation, there's a clause in there that says this protection will not operate in all circumstances.
So in this situation, I could potentially be touching my EV car,
Yeah.
metallic part of the car,
Yeah.
the greater mass of Earth.
Yes.
What sort of voltage might be going through me according to this?
Well, 72 volts according to this.
And with my device screwed to the wall that's monitoring changes in voltages,
And that's not going to happen. It's just going to carry on. With
so it's not going to help me.
No, because it hasn't gone outside the 207 to 253 volts.
All right, so I've got by the third house in the street.
Yeah, exactly, yes. Yeah, good. Okay.
All right, okay.
Yeah, that one's suddenly gone up in value and these have gone down.
Oh yes, yeah. Wow. Yeah.
So this is based on the fact that having done the risk assessment analysis, this is safer than installing earth rods badly.
Okay. Yeah.
Okay.
Yeah.
Or not bothering to put the earth rod in at all and having no protection, which is where we were under the 17th edition.
We were. Yeah.
Yeah.
Okay. Oh, it takes a moment to think about that,
Okay,
doesn't it?
so-
So that's monitoring voltage within the EV charging unit.
Yeah, or a separate device fitted to protect it. So you can do this two ways. You can buy a charge point that has this voltage protection in it.
All right.
Okay, and some manufacturers are doing that.
Fine.
Some don't, so you need to buy a third-party device to provide that protection. I think the only point to make out is this thing about risk and safety. I think we mentioned it again. So this is still considerably safer than we were a couple of years ago.
In the 17th.
Yeah, but there are still circumstances where it's going to lead to electric shocks.
And is that relating to the fact that it's only about 500 pen faults a year?
Yeah, it's 400 to 500
Yeah.
reported under the ESQCR each year. About 10% of those reported actually causing injury. So,
Right,
So we're talking 50 at the moment, but the more electric vehicle charge
Just about
points
to say
go
that
out,
is where you're going wrong.
you're going to have more likelihood, aren't you? Yeah.
Yeah, so as we get more electrically hungry for our vehicles,
Yeah.
obviously that risk factor goes up.
Yeah.
So before we get to the excitement of indent number 5, there's a question the electrical industry keeps asking me, Chris, and maybe you can help me with it, on indent 4 about nuisance tripping.
Okay, yes. So the Indent 4 says you've got to trip if the voltage goes outside the range 207 to 253 volts.
Yes.
Okay, but 207 is not really a problem. Don't often see that. 253, you do see a lot on the distribution system. If you're close to the transformer, if it's been tapped up because there's a long line maybe, or if you've got lots of PV installations close by, that voltage often travels up to 253 or a little bit above, and that will be enough to trip out any electric vehicle chargers that are following Indent 4.
And I can back that up. The college I used to work at, we had a test rig there where we were often measuring voltages,
Yeah.
and often I saw 253 or slightly greater. We had our own supply transformer and our own PV there, so of course that would cause a problem to the items that follow Indent 4.
That's right, and it's the same where I live. It's a reasonably new estate, close to the transformer. There's a few houses with PV panels. In the summer, we're regularly seeing the voltage going up to those higher levels.
Okay, so let's get into Indent 5 then.
Okay, so Indent 5 was introduced by the IET in this amendment to promote innovation. Okay, so you've got the rules that have been around for a long time, 70 volts, earth rod, all the rest of it. But as new technology develops, you see things changing, new ways of doing things. And the IET's view was, well, if the manufacturers can be encouraged to come up with new ways of protecting EV charge points when they're installed outside, which make it safer, cheaper, easier to install, then that's got to be a good thing because it will promote the take-up of electric vehicle charge points, which is important.
And we saw, didn't we, after the 18th edition dropped, Amendment 1 was on its coattails really quickly,
Yeah.
so it's nice to think the IET have almost put a little cushion in there saying if industry and technology goes faster than the regulations, that actually Indent 5 comes into play.
Yes,
But
that's
is
right.
it in play now, Chris?
It is, yes. So Indent 5 was brilliant because we've been working on a solution for the earth fault protection problem even before the 18th regulations came out, okay, 18th edition. We wanted to make the installer's life as easy as possible.
Right.
So Indent 5 basically says that the manufacturer has to provide protection that isn't any less safe than Indent 3 or 4.
Okay.
And with the pen fault protection, what we say is that we will detect every time, any circumstances where there's an indication of a small current flowing where it shouldn't do, through you touching the car,
Okay.
we will trip the output.
Okay.
Regardless of whether or not the 70 volts has been exceeded, regardless of whether or not your voltage has moved beyond the threshold. And we see from Indent 3 and 4, there are times when you won't trip
Right.
even though there's an earth fault that could, a pen fault, sorry, that could cause you a nasty shock.
A potentially dangerous situation.
Exactly. Yeah.
And another bit that I really like in there that isn't in that part of the technology is that also the device will, if I wired that in, it had no CPC connected to it, it also wouldn't
It won't work. You'll boot up and it will complain and say no CPC, and then you've got to do something about it.
Can we see it in action then? Let's see Zappi 2 in action.
Yeah,
then,
okay, so Zappi's alive, but the display is the backlight's off. So let's just wake up the backlight, just with a little knock. And we've got the simulation we had before.
Right.
So we've got a 3-phase supply in the street. We've got a single-phase supply to the house, which we've tapped off one phase.
Yes.
And what we're looking at the moment is that the load in the street is balanced, the pen conductor is intact, so everything is great. The voltage is in range, everybody's balanced, there's no fault current.
But nobody's got an issue. No one's got an issue at this stage. Any EV charging point has no issues at this stage.
No, this is fine. This is how the system should operate,
Brilliant.
how it's designed to operate.
So what would you like me to introduce? A little bit out of balance
Let's
first?
get some imbalance first of all.
Okay, so we're slightly out of balance.
Yeah, neutral conductor's intact.
Yes.
It's still doing its job. The CPC to true earth, Mother Earth is fine.
Right.
Okay, let's have a little bit more imbalance.
Do you want more imbalance?
Yeah.
Okay, so a little bit more.
Okay, still good, everything fine.
Which is what we expect.
So now let's damage that pen conductor in the street. So introduce the fault, please.
So I'm going to break the combined neutral and earth in the street. Okay.
All right. And actually what happened there was Zappi tripped because we'd left it in a fault condition. So
Right, okay, so explain it to me. So the moment the pen conductor broke in the street, there was a fault condition that was seen by the Zappi. Just unpeel that for me then. What was happening there then?
So we're simulating somebody touching the vehicle while it's
makes
charging.
sense if it was charging, yeah.
And in this case, they were leaning against the car having a chat. The conductor was damaged. Zappi picked it up straight away and tripped.
So the minute the pen fault in the road happened, it was at the same point someone was touching the car and greater mass of earth, already gone.
Okay.
That proves a really good point.
So let's take that back in slow motion a little bit and explain. So I'm going to disconnect the vehicle.
Okay.
That's a vehicle simulator.
Yeah.
I'm going to reset Zappi, so you have to hold it in the reset button for 3 seconds. That's a really deliberate reset action.
Yeah, so you've got to want to press that, haven't you?
Okay. Zappi self-checks. Checks the RCD, checks the PE conductor, makes sure everything's okay, goes through startup, and then when we then connect the car, Zappi will then put the output live for the car to charge.
So what we're saying now in this situation, no one's touching the car and greater mass of earth, but there's a potential that they could now go and do it.
There's. So looking at the voltages on the voltmeters.
Okay,
Okay, we're on line 1 here,
right,
218 volts, so we wouldn't trip if we were following Indent 4.
Well, you just told me we're in the fault conditions.
We are. Look, we've got 72 volts on this. So the pen fault's broken.
But if I had a different device that we've talked about, or a different solution to the problem,
Indent 4,
I'm in a world of pain.
You are. Yeah.
Literally, maybe.
Okay.
Okay. So I'm concerned. Yeah.
So what we can do now is we've got a meter here just measuring the milliamps flowing through the person leaning on the car.
Right.
And this box here simulates that person. And I can gradually reduce the impedance of that person.
Right.
So going from a big bloke with dry hands, high impedance, and small current. A woman's probably got a lower impedance and a child a lower impedance again. So we'll gradually increase the fault current.
Yeah.
And as that increases up, at about 19-20 milliamps, this will trip. There we go.
Right.
And actually that was only reading 16, but because the meter wasn't catching up.
Oh, right, okay. So it detected the fact that current started to rise and the charging unit dropped out. It didn't detect a voltage change because they're within the regions that we've talked about previously.
Exactly, yeah.
All right, so would it go on the voltage as well?
So if we can detect a problem, why not trip on it?
Absolutely.
Okay, so we don't want to have nuisance tripping.
No,
so 253 volts is no good.
No.
But if we just go a little bit higher than 253, so we trip at 12%.
Okay.
So that avoids the nuisance tripping. It would trip straight away on this phase because we're way out. Okay, so we want to make sure, why would you hang around if you could find out? But then if we haven't tripped because we're at 253 and the pen fault comes in, then we'll detect that fault current and make the system safe and protect you from a dangerous electric shock.
Right, so you're using multiple ways to protect the person. So so there's not one solution to the problem. No. You pick up every solution or every problem that's there and put a solution to it.
Yes. And in the 3-phase Zappi, we do exactly the same. We look at the voltages. If they're out of range, we'll trip
Right.
So we'd look at every single indication there's a fault, and we'll make sure we act on it.
Wow. So it's not just safe, it's super safe in that respect.
Yes.
Just to clarify this bit, because this is the bit everybody's worried about fitting these things for some technical reason, let me rest assured it's no different than a shower screw to the outside of your building. Okay, so there's IP ratings, etc. And that's why I always say that. It's probably a 6mm cable or a 10, similar to a shower.
Yeah.
And when I connect it in there, it's just a line, a neutral and CPC and nothing else?
Exactly, because the RCD is built into the Zappi.
Yep.
So as long as you're not burying your cable in the plaster, so there's regulations why you would put an RCD in the consumer unit. As long as you're not doing that, you don't need an RCD, just put a standard MCB in your consumer unit.
Yeah.
All protection's built in here, so run the cable to Zappi. It's got a Type A RCD with a 6mA DC, so it covers that. It's got the earth fault protection built into it, so it really is just run a cable, wire it up, do a nice neat job, and you'll get a gold star from Mrs Goggins. Yeah.
So it doesn't sound difficult, does it? It's a radial circuit, often clipped maybe around a garage, or maybe going outside on it. You can use a steel or armoured cable. Yeah, if you've got any of those sort of issues. It's not difficult to wire to, and when you get there, you've got to make a line, a neutral and CPC connection, and the rest of it's taken care for you.
Exactly, yeah.
Oh, yeah. So, yeah, obviously, that looks to me like that's a really good solution. And you come under the heading for Indent 5 with the technology built in here and everything above it as well.
Exactly, yeah.
That's really good. We'd like to thank Dr. Chris Horne from Myenergi for coming in and showing us this and talking us through those pinch points that the electrical industry are currently facing themselves. If you're currently fitting EV charging points or you're thinking about doing it in the future, remember we're always happy to hear your comments below. So please make sure you do those comments. And once again, Chris, thank you very much for your time.
Thank you very much.